Now we will review the laws of indices, which are summarized here. It states that the first law, whenever we have got two numbers with the same base, for example, x, and having different indices, and the numbers being multiplied, then their powers are added. Like, for example, we have got a number 3 with power 2 and another 3 with power, let's suppose, 5, and we need to multiply them. In that case, we will write the base, which is 3, only once, and their powers are going to be added, 2 plus 5. So 3 raised to power 7 is the answer. That is the use of this rule. And now when there is a division sign in between them, that means the numbers are being divided, then their powers will be subtracted. Like 3 raised to power 5 divided by 3 raised to power 2. That will give us 3 raised to power 5 minus 2. That is 3 raised to power 3. And now, power of a power. This rule. It states that whenever a number has got two powers, second power as the power of the first one, then both the powers are being multiplied. That means, for example, 3 raised to power 2 whole raised to power 5. That will give us 3 raised to power 2 times 5. That is 3 raised to power 10. And any number having power 0, that will be equal to 1. Means a raised to power 0, that will be 1. 2 raised to power 0, that will be 1. Even 100 raised to power 0, that will be 1. Or 1 by 2 raised to power 0, that will be 1. Or negative 5 raised to power 0, that will be 1. So no matter whatever the number is in the base, if its power is 0, then the answer is 1. Then this is the law of negative indices. A number is having a negative power. When it will be shifted in the denominator, its power will become positive. And this holds the vice versa as well. That means, for example, 3 raised to power negative 2 can be written as 1 divided by 3 raised to power positive 2. Or you can understand it like this. If we have got 1 by 3 raised to power negative 2, means the power of 3 is negative already in the denominator. When it will be shifted in the numerator, it will become 3 raised to power positive 2. Means number goes from numerator to the denominator, the sign of the power changes. The number goes from denominator to the numerator, the sign of the power changes. Then we have got fractional indices, x raised to power 1 by 2. That means square root of x. Similarly, x is raised to power 1 by 3 means cube root of x. X raised to power 1 by 4 means fourth root of x, and so on. So in general, we can say if there is any number a, for example, and its power is 1 by n, that means a is having an nth root. So with these rules, let's start some of the questions from this topic, laws of indices. This is exercise 2.8, and we need to simplify it. X raised to power 2 times x raised to power 6. So we will apply the first law of indices here. The powers are going to be added when the numbers are being multiplied with the same base. So x raised to power 8, that is the answer. Same goes in this case. We will write a only once and we will add the powers. So the answer is a raised to power 10. Similarly here, this question can be done in two ways. Y raised to power 2 plus 0, that is y squared, or you can understand it by the use of 0 index. As we discussed, any number raised to power 0 is 1. So we can write down y squared times 1, which is y squared. Then for this will be x raised to power 9 plus 4, that is x raised to power 13. Okay, it goes on with the same pattern for part I now. You see, the coefficients are 3 and 2 respectively. So first of all, we'll multiply the coefficients. That will give us 6. And then we'll apply the rules of indices on the variable x. X raised to power 4. And then this power gets added. And that will give us 6 x raised to power 7. Same goes for the remaining parts. Let me first of all, for example, solve part m. This is 5 times 3, 15 x cubed. And here it is 4 times 2, 8 z6 plus 1. That is 8 z raised to power 7. So this is how these questions are to be done using the first rule of indices. X raised to power m times x raised to power n. Then we write the base once and the powers are added. Okay, now it is question number 2. It contains the use of second law of indices that we studied, x raised to power m divided by x raised to power n. That will give us x raised to power m minus n normally, provided that m is greater than n. Okay. So part A will give us x raised to power 6 minus 4. That is x raised to power 2. Same goes for part B, g raised to power 12. Since this is a division sign in between, so we'll write 12 minus 3. That means g raised to power 9. Then similarly, in part E, for example, you can understand it in two different ways. Either you can say that s is being divided by s raised to power 5. So we can write it down as 5 minus 1, that is s raised to power 4. Or we can understand it in a way that s raised to power 5 means s being multiplied with itself 5 times. And in the denominator, we have got 1s. So we can cancel 1s and we are left with 4s in the numerator. So that means s raised to power 4. Okay, now it is part J. 3 ones are 3, 3 twos are 6. That means 1 by 2 x raised to power 4 minus 3. That is 1 by 2 x raised to power just 1 or just x. Similarly, for part K, we can simply say that we can cancel them. The coefficients 5 threes are 15 and x cube gets cancelled out with this. So 3 times 1, that is 3. Or we can understand it in another way as well. 15 x raised to power 3 divided by 5 x raised to power 3. Cancelling them together and then applying the rule of indices. 3 x raised to power 3 minus 3. I'm shifting this in the numerator. So that will give us 3 times x raised to the power 0. And we discussed that any number raised to the power 0 is 1. So that's why 3 times 1, that is 3. That is the answer as before. Okay, now for part n, for example, we can have 4, 4s are 16, and then 4 would be the same, a raised to power 2 minus 1, b raised to power 2 minus 1. That will give us 4a and b. That's the answer to this one. And for part O, 12xy squared completely gets cancelled out with its denominator. So we are having ones are 1 by 1, that is 1. That is the answer. So this is how we need to solve these questions. It's now question number 3. Power of a power. We studied this rule, a raised to power m whole raised to power n. Whenever there are two powers of the same number, the powers get multiplied like this. So in this case, a raised to power 2 times 2, we will have a raised to power 4. Here we will get v raised to power 2 times 3, that is v raised to power 6. In the same way, we can have for part E, for example, 2 raised to the power 5, I separate it like this, and then x square whole raised to the power 5. That will give me 2 raised to power 5, then x raised to power 2 times 5, that is 10. And 2 raised to power 5 means 2 multiplied with itself 5 times, which gives 32, x raised to power 10. That is its answer. This is the application of the rule. For example, a times b, we have got two numbers and whole power is n. Then that power shifts on both of them, a raised to power n, b raised to power n. Okay. Same goes for part F. 3 raised to power 2, c square raised to power 2, d square raised to power 2. That means 3 square is 9. Then applying this rule here, there are two powers of c, both being multiplied. 2 times 2, that is 4. And same goes for d, d raised to power 4. So that is its answer. And then it is part L, for example, 4 square, g square, h square whole square, which will give me 16 g square h raised to power 4. And for part O, for example, x square by y, whatever the base is, if its power is 0, you straight away write it 1. Any number, any base raised to power 0, the answer is 1. So its answer is 1. Okay, for question number 4 now, use appropriate laws of indices to simplify these expressions. So we need to apply different laws together. Here, 2, 3, and 2. The coefficients are being multiplied together. So we'll write 2 times 3, that is 6. 6 times 2, that is 12. And then x raised to power 2, raised to power 3, and then raised to power 1. All are the powers of the same variable, same base. So that's why we can add them using the first law of indices. So this is 12x raised to power 6. Okay, let me solve its part E, for example, or part D first. Let me solve this one. There are two powers of the same number, so we'll apply this rule. So 2 times 2, 4. Then divided by 4x squared. We can write it down, x4 divided by 4x squared. Applying the rule of indices, 4 minus 2. That will give me 1 by 4 x raised to power 2. And that's its answer. Okay, then Let me solve the next parts. Part E, for example, 11x cubed times 4, and then this power 2 will be shifted to both of them. A square raised to power 2, b raised to power 2. So now the coefficients are being multiplied. 11 times 4, that is 44. Then x cubed, and then a raised to power 4 and b square. Since now these bases are all different, so we cannot further simplify them. So this is going to be the final answer. Here in part F, I'm going to multiply this with this one and then with this one. This is the use of the law, the distribution law. So 4x cubed, because this is actually, if I do it here, 4x times x squared, then plus 4x times 7. So this is 4x raised to power 1 plus 2 plus 4 times 7, that is 28x. So that will give us 4x cubed plus 28x. That is the answer. So same goes for part G, for example. 4x times x squared minus x squared times x cubed, which will give us 4x raised to power 1 plus 2 minus x raised to power 2 plus 3, which will further give us 4x raised to power 3 minus x raised to power 5. That is its answer. Okay, then for part H, x raised to power 8 divided by x raised to power 3 times 2, which will give me x raised to power 8 divided by x raised to power 6. And now applying the second rule of indices, x raised to power 8 minus 6, that is x raised to power 2. In part K, for example, this will be a4 raised to the power 3, b square raised to the power 3. That will give me a raised to power 12, b raised to power 2 times 3, that is 6. So we cannot further simplify them because these are separate numbers with a different basis, so that's why. So in part N, for example, this will be 4 2s are 8, x raised to power 2 plus 3, that is 6. Then divided by, this will completely become 1, divided by 1. So that will be 8x raised to power 6. And finally for this will be 16x4 y 3 2s are 6 and divided by 2 raised to power 3 is 8x cubed y cubed, which will give me 2x raised to power 4 minus 3, that is 1, and then y raised to power 6 minus 3, that is x cubed. So 2xy cubed, that is its answer. So that completes the exercise.